there's been some, and this is an ongoing discussion. For example, on Wednesday on the weekly report or the weekly basement discussion here on the LaRouchePAC site, this was discussed from the standpoint of Vladimir Vernadsky and the ability to look at the human species as a geological force or as a biological force, and how if you examine the characteristics of the human species over historical time, it would seem as though you were observing a different species, that we change in ways that are seen only over evolutionary time in the biosphere itself. What I'm going to take up today is this Keplerian dimension of things. Kepler, the scientist, had put on the table and developed, really created modern science, and he did it in a way where he was very explicit about how he thought about those things and about the resonance, the connection, the similarity between the functioning of our minds and the functioning of the universe as a whole, which not only brought us science, but it brought us a proof of the magnitude of the power of the human mind, of the real magnitude of the human soul. So, to address this question, how does Kepler give us an answer to what is mankind? LaRouche said, take two approaches to this. The classical approach of what Kepler had done in his day, and then also take the modern approach and how China is embodying this with their work at present. So first, the classical part of things. Kepler used a technique that was developed by Nicholas of Cusa, a technique that Cusa called the coincidence of opposites. And he used this to develop a new language for science, for astronomy in particular, and to break through the Aristotelian way of thinking, which was based on logic, on syllogisms, frankly on words, on playing with words, categories that concepts are defined in, how phrases, logical phrases come together, and it was not based on letting nature itself speak. One particular tenet of Aristotle that Cusa and Kepler demolished was Aristotle's conception that you can't have both A and not A. This is something that Ayn Rand also gets very excited about. I guess that's an aside. So you got Aristotle, you can't have both A and not A. There are not contradictions. True knowledge is an avoidance of contradiction. That's how you know that you're right. Cusa gave examples of how that's actually not how to be right. It's certainly not how to discover anything. So Cusa distinguished between the world of the senses, the rational level of understanding based upon those senses, and a higher intellectual level of understanding that was reached only by contradictions among those senses. As an example of this, we can take how Cusa uses the infinite in Book 1 of his work called On Learned Ignorance, Didacta Ignorantia. There, Cusa uses geometrical analogies extended to the infinite to give a way for his reader to understand what his conception of God is as a specific lack of knowledge. We're going to be hearing more about that, a specific kind of lack of knowledge, a learned ignorance, a specific kind of ignorance is itself a form of knowledge for Cusa. How could that be? He gives some examples. He says, one thing, in the infinite, a circle and a line no longer oppose each other. They aren't really different shapes anymore when you take these concepts and extend them to the infinite. This is a way of making a point about the infinite, even though obviously a circle and a line are easily differentiated when they're of a finite size. He says that God is the type of maximum to which nothing is opposed, not even the minimum. How can you have a maximum that's not opposite to a minimum? What kind of maximum is that? He says that we would attain a shadow of this vision of God by consideration of ways in which our understanding failed to reach him, by developing a specific shape of the ineffable, by knowing in what way it was ineffable, by what way specific contradictions in thought could be created to get at it. That's really only a shadow of what Cusa does. people who've read it, it's a tough thing to try to summarize briefly. Partly because his whole work is a constant challenge to your thinking and not adding things to your thought. This act of thinking, this discovery process that he enlivens in the mind, is itself the way to an understanding of God in his view. Now, in Book 2 of this work, of On Learned Ignorance, Cusa takes up the universe, the created world. And he does this by looking at how the universe itself defies logic and defies understanding based on sense perception, based on the senses. One consideration that he uses is that there is no perfection in the created world, in the universe, including no equality. He says there is only true equality in God. We won't find it in the universe itself. And that would mean that such things as a perfect circle, although you can imagine it geometrically, could never actually exist. For an actual circle to exist, each point on the circle would have to be exactly the same distance from the center. And Cusa says, how could it be that they're so equally the same distance from the center, these points, that they couldn't have been made more equal? He says you can't have two lines that are actually exactly the same length. That concept involves an impossibility. Equality itself could not be embodied in a line. Or in motion. Cusa says that two motions couldn't be identical either. How could two moments of motion be so alike that they couldn't have been made somewhat more alike? So from these considerations, Cusa comes to conclusions about astronomy that weren't actually shown to be true for quite some time. For example, he says that there is no way to have circles in anything, including in astronomy. No planet could move in a circle. Circles couldn't exist because they involve that absolute equality. He also said there could be no absolute equality of motion. There could not be uniform motion, because that would again call on this equality that could not exist in the universe. So in a world dominated by an Aristotelian outlook, which said that although the earth might be changeable, the heavens are static, they're perfect in their stasis, in their staying the same. The heavens are perfect in their geometrical existence. They're perfect, God traced them out with a compass and a ruler. Cusa says, no, it actually can't be like that. It's impossible. And that these concepts will not be able to be the guiding understanding behind astronomy. He was way ahead of his day on this. Now, to say something about, to get into Kepler, we have to have some background on what astronomy is, on how it got to the state it was by the time Kepler hit the scene around the year 1600. So, among the stars in the sky, there are some which move. There's also obviously the sun and the moon, which move quite a bit, but also some stars themselves move over time. That although almost every star stays in place from night to night if you go out and look at them, you find some that are moving stars, wandering stars. The planets called these stars wanderers. The Greek word wanderer gives us the English word planet. That's where the word comes from. So let's take a look. We see in this video here a type of motion that these stars might make. So here you've got, let's say, Mars, and we're watching it move. This is sped up over years and years. Every couple of years, Mars moves backwards. You have to imagine against that background that we have all the constellations, Cancer, Leo, all the other ones. And so Mars moves mostly in one direction, but also goes backwards. It only goes backwards when it's opposite the sun. That is, when it's in the constellation that's at its peak at midnight. Mars always moves quickly when it's near the sun, when we see it at dawn or at dusk. Backwards when it's at its peak at midnight. And you can see that these retrogressions, these going backwards, they have different sizes and different parts of the orbit. So Mars has a backwards motion, which is somehow tied to the position of the sun. It also has some parts of its orbit where it seems to overall move faster, and some parts where it overall seems to move slower. So how to explain that? That's the difficult thing. So Claudius Ptolemy, you may have heard of Ptolemy, the 2,000 years ago. He had written a book, the Syntaxis, also known as the Almagest. He wrote a book where he explained how the planets moved, sort of. He explained how that dot in the sky would move, at least, although he didn't claim to know anything about what was physically happening. The way he did it was he used 2 circles for each planet. So each planet would overall move on a circle through all the stars, through all of the constellations, and on that circle would be a second smaller circle that spun more rapidly and would cause, by their combined motions, Mars or any other planet to sometimes get pulled backwards, to have these backwards motions. The other aspect of things was to explain the fact that overall there's a part of Mars's orbit where those retrogressions are shorter, and there's another part of the orbit where they're longer and they occur more commonly. To explain this, Ptolemy used the second thing that Cusa proved couldn't exist. He used a certain kind of uniform motion. So what he did was, and we'll see that in this video you see here, that instead of having the Mars simply move around the Earth, this is ignoring the second circle upon it, he first tried moving the center of Mars's orbit off to the side. And that helped somewhat. And then you see the motion there. He put the center of Mars's orbit in between the Earth and the point on the right around which Mars moves at a constant speed. That point on the right is called the equant. That was a difficult thing to take in. Let's watch that one more time. So you can see how the retrogressions would look if Mars simply moved uniformly. Here, we move it off-center. The retrogressions are in the right spot, but the lengths are long. One more adjustment, we separate the center of position and the center of motion, and Ptolemy matches the observations pretty well. And that was his goal, to match the observations. So that point on the right is called the equant point. We'll come back to that with Kepler. So we've got a circle, which Cusa doesn't accept, and we've got uniform angular motion around another point, which Cusa wouldn't accept. Ptolemy was, a millennium and a half before Cusa. Then there's Copernicus, Nicholas Copernicus, who I'm sure everybody's heard of, who had the planets move around the sun, or more accurately, had the sun stand in the middle of the moving planets. And he actually had more circles in a certain way than Ptolemy. He had the planets move on a circle, on a circle, on a circle, around a point near the sun. That was how Copernicus explained the motion of the planets. And the goals of these guys, it was to accurately predict where you'd see a dot in the sky. It wasn't a physical theory. Physics didn't really have anything to do with the heavens. So this is where Kepler comes into things. And Kepler, he was a follower of Cusa, and he was convinced ever since his youth, as he was in school, he wrote a school essay on this topic, that the planets, they do go around the sun, but not in the way Copernicus did. Not that the planets are moving and the sun's sitting in the middle watching them, but that they went around the sun because the sun was the cause of their motions, a physical hypothesis. That the sun physically caused the motions, not God with a compass and a ruler. So in one of his very major works called The New Astronomy, Kepler used Cusa's technique of the coincidence of opposites in a specific way to lead to a higher truth, to force people to consider, and he then demonstrated his physical concept. He did this through what's called the vicarious hypothesis. In this, Kepler asked one question, and he got multiple different answers. He got contradictory answers. Would he then try to simply avoid the contradiction, or would he use the contradiction? He used it. So let's get into this. The question that Kepler asked that got multiple different responses was, how far away is the center of Mars's orbit from the sun? what's that distance? Well, he answered the question twice by using two different aspects of observations, longitude and latitude. Longitude is the motion of the planet overall around the stars through the constellations. Latitude is the motion above or below the central line called the ecliptic, which goes through all of the constellations of the zodiac. So when he creates his vicarious hypothesis, Kepler uses those assumptions of his predecessors, the circle, the equant, geometry, mathematics. He uses them to create a new model, better than anything anyone had seen before. It worked incredibly well. It was based on the real sun for the first time ever. The actual sun itself was the center and cause of planetary motions, which were still then made by circles and uniform motion. That worked great. It gave a distance between the sun and the center of Mars's orbit. In this video, we'll see how he used a different kind of observation to get another answer. So here again, you've got longitude, the motion of Mars around the ecliptic through the signs of the zodiac. Latitude would be Mars's motion above or below the ecliptic. By using some clever trigonometry, Kepler used the fact that Mars goes above and below this plane of the Earth around the sun. And by solving for some triangles, he was able to figure out all of the distances that you see here. Meaning he was able to get that distance in the middle. How far away is the center of Mars's orbit from the sun? He got this green length. Now, there was one trouble. That green length was not the same length that he had gotten before. It wasn't the length that he had in the vicarious hypothesis. So in this next video, we'll take a look at a comparison between the two. What we're going to see is how, when Kepler adjusts the vicarious hypothesis to use this length, which came from latitudes, a problem arises. And this problem was key in his work to reform and develop a new astronomy. So we have that green length here, and if you can see it, there's another purple length. Oh, okay. So what you see here are two different places where Mars's center of its orbit could be. The orange one is based on latitudes. The red one is based on longitudes. The difference between where these models say that Mars will be is 8 minutes. A minute is a 60th of a degree, just like it's a 60th of an hour in time. So, to say that again, Kepler created a model using longitudes. It worked great. It included a distance that was in doubt, that was derived indirectly. He then used latitudes in that model that you saw with Mars coming up and out of the plane to get its distance more directly. That new distance, which was indicated in green, doesn't work with the other one. If he adjusted his vicarious hypothesis to have that green distance, it broke. So he got two contradictory answers. Either the distance is the green distance or the purple distance. It would either be the orange center or the red center here. Those are two different distances. And they're also two different positions. Is Mars seen along that red dashed line or along the yellow dashed line? Well, you can't have it both ways on either of them. You can't have two different distances. You can't have two different positions. And what the data showed was opposite for each. The longitude data suggested one direction. The latitude data suggested one position of that center. So we have two different answers here. What does this mean? Well, both answers can't be right. They preclude each other. When you have one, you lose the other one. And Kepler says that this 8 minutes difference is the key to a reformation of astronomy, a key to a whole new approach to things. So what he concludes is that this proves that the approach was wrong, that trying to explain things from the standpoint of the senses, of motion itself, wouldn't do. we had to bring in a physical cause for why the planets moved the way that they did, going beyond the senses. We have to find a unifying conception under which the contradictions would no longer exist. Kepler did that. He made a physical astronomy. He explained how the sun would cause the motions of the planets. He had only one measure for that distance between the sun and the center of Mars's orbit. He had only one position that Mars would be, and it was right. And he forced people to break out of that Aristotelian view and bring physics out into the heavens, to make cause the reason for why things are. And he used a contradiction to create that new thought. While Cusa showed that a shape couldn't be the same over time or a cause, or that equal motion itself couldn't be a cause, a principle, which is always equal to itself, that's a different kind of thing. A relationship between the planet's distance from the sun and its speed, that's a different kind of thing. And that's what Kepler had done. Yes, he did say that planets moved in ellipses, but the ellipse was a result, in his view, of two different powers acting on the planets. One moving them around the sun, one causing them to come closer and farther from it. So the ellipse, Kepler's ellipse, was not a shape, like Copernicus's circles. It was a result of a physical process. So that was, I'm aware that was rather in depth, and that might not have all been understood. I can refer people to both the science.larouchepac.com site for more on this, as well as the video called Metaphor and Intermezzo, and we'll have links after the show in the video description on YouTube for that. So when multiple opposing answers all seem equally appropriate or inappropriate, that indicates that the language we are using lacks the ability to actually comprehend the topic we're looking at. That's the Cusan approach of metaphor employed by Kepler. That wasn't the last example of it. Let me give a few examples of some other questions that have multiple answers that are equally right or equally wrong, however you want to look at it. So, how would you answer this question if I were to ask you, how many sides does a circle have? You might have an answer you're thinking of right now, whatever that answer might be. Try to think of another answer that somebody else might give. Compare those two answers. Your answer, a second answer. Do you think you could determine who was right and who was wrong? You might even have a third friend with a third answer. I asked this to a group a couple weeks ago, and I got three answers. One side is just one curved side. Infinite sides, a circle's like a polygon with an infinite number of sides. Or zero sides, because sides are flat and a circle's not flat. Now, I think you could spend a long time arguing over those three answers and who was right. I think the point to take from it is that there's something wrong with the question. There's something about asking how many sides does a circle have, which is inherently a weird question. Here's another one. Let's go to the idea of eureka. So eureka, this use of this phrase eureka, I have found it. This goes back to Archimedes, who was, while taking a bath, figured out how to solve a problem of a possibly counterfeit's not the right word, a dishonestly alloyed crown. So there was a crown or some piece of gold made for a ruler, and he thought that maybe there was actually silver mixed into it, that it wasn't pure gold. He said, Archimedes, can you figure this one out? So Archimedes was, it was his task, a job for him. The story goes he got into a bathtub. As he hopped in, the water rose up over the sides because of his body in it, and he says, eureka, I found it. By putting the crown in water, he could measure its volume by seeing how much the water level moved. If he knew the volume of the crown, and he knew how much it weighed, he could get its density. Now, I looked up some modern-day measurements of the density of gold, 19.3 grams per cubic centimeter, and silver, 10.5 grams per cubic centimeter. So if you found out what the density of the crown was, and it wasn't 19.3, but it was a lower number, that would mean that it had that much silver in it, mixed with the gold, and you could actually find out if the goldsmith was cheating you or not. So that's an interesting story. So those numbers I gave for gold and silver, the densities of it, what if I were to ask, what's the density of carbon? carbon's an element, like gold or like silver. Why don't you try, I'm going to leave this one as a puzzle. Make a note to it, look up yourself on the internet, see if you can figure out what the density of carbon is, and see if you run into any troubles with that. Got another question. What's the atomic mass of uranium? How much does an atom of uranium weigh? Not an answer. There's different kinds of uranium. This was the language of nuclear science going beyond the language of chemistry. How many terabytes or petabytes or exabytes of storage are in your brain? What do you think about that question? Is LaRouche a conservative or a liberal? Are you Fox or MSNBC? There's a lot of questions where posing the question makes it impossible to give a good answer. And in the most profound way, it's the contradictions between our current best efforts at understanding that pave the way to the metaphorical breakthroughs of developments of fundamentally actually new concepts. And then that's what the real history of mankind is, of doing that. You might ask yourself, what does the concept of rightness, of justice, what is that concept's temperature? Is it hard or soft? Wet, dry, furry, smooth? They're just silly questions. So, yes, when the answers are specific non-answers, that lets you go beyond things the way Kepler had done, and the way that, to give some other examples, do the same as well. It's those contradictions that mean there's more to discover. It's those contradictions in logic that let Kurt Gödel prove that Bertrand Russell was an idiot, and that his approach to try to turn all of science into logic and mathematics was impossible. That contradiction that makes a joke funny, or a reconceptualization in a great piece of music, that contradiction is a mental process in our minds that resonates with the whole universe, in which creative thought itself is a characteristic principle and itself a force of nature. So let's take a look, moving into the future, of this Keplerian approach. By applying new discoveries in the way that Kepler had done, creating the mental tools for the existence of modern science, we have written chapters and books in our history. We've created human history. As LaRouche has been emphatic, man is his own maker. We make ourselves. We set our own history. We have history. There is no history of penguins. If there is, it's about people's interaction with penguins. Or possibly over a very long-term, thing about how climates have changed or predators have differed. But penguins themselves don't write their own history. Things happen to them, and that tells you about, if there's anything interesting to find out about the history of penguins, that would be it. But we create these things. Think about some of the things that created the new chapters in the book, or the new book in the volume. We had the Stone Age. What got us out of the Stone Age? The seemingly magical ability to transform rocks into metals. Rocks and metals are very different substances. It's hard, it's not very often that you're not sure whether something that you see is rock or metal. They're pretty different. And being able to change them, that was the beginning of the Bronze Age. We had the Iron Age. We had the development of agriculture, being able to plant seeds, to find food where you would like to find it in the future instead of looking for it, to create new kinds of food, to develop corn, to do grafting, to develop new fruit trees. This is something that we did. We made new kinds of life. We've been making new kinds of life for thousands of years. This isn't a new thing. Astronomy, navigation, the use of compasses for your directions, reshaping the land with irrigation, with canals, using mills to do the work of animals or of ourselves. The Renaissance, the great breakthroughs in art and music that let us develop a more powerful image of ourselves, which itself would enable us to do more in other fields. The modern science created by Kepler, Cusa, Leibniz, Gauss, Riemann, others, the list goes on. These things unleashed tremendous changes in our relationship to nature. Those things defined us as a species, as a changing species, our most characteristic. Creation of new materials, the chemical revolution, electrolysis to create metals that were almost impossible to separate before, like aluminum. It's a common metal now, Go back 150 years, it was incredibly rare and one of the most expensive substances that existed. It was used to cap the Washington Monument because it was such an exotic metal and such an expensive one. Today, it almost seems like, why would you put aluminum on the top? That seems kind of cheap. Is it just Reynolds wrap? But not at the time. At the time, it was something very special. Or, just give a few other examples. Painkillers, antibiotics. You would not have a hip replacement surgery if you didn't have, I believe, anesthesia. That's sort of a necessity for a lot of the things that people get done today, unless it was a life or death surgery. Medical scans, etc. So these different eras, the broad-ranging different eras of mankind, the physical world of the Stone Age, the chemical world of the Bronze and Iron Ages, and the electrical age, the nuclear world that we're moving into, those are the, creating a new book in mankind's history. We make ourselves in that way. And those are the things that are the real topic of economics. Gambling is not going to be an interesting chapter in the history of mankind. When a history book's written 1,000 years from now about all the things that made it possible, all those breakthroughs around the time of the year 2000, plus or minus a few hundred years, that real shift in mankind's history when we finally eliminated oligarchy as a predominant force on the planet, when people are looking back at this in 1,000 or 10,000 years, no one's going to be very excited about interest rate swaps. No one's going to be very excited about Wall Street gambling. It's not an essential part of what we are. So think about now, let's get to where China's going. The moon. China's going to the moon. They're writing that next chapter. By moving there on a permanent industrial basis, that's the outlook. By planning to use the helium-3 that exists there as the new, most powerful fuel for the next stage of human development, of nuclear fusion, China's setting a course not only in a physical way, with that next chapter in our history, the next chapter of man the maker, but also very powerfully as a self-concept, an extraterrestrial self-concept that doesn't currently characterize most of our thinking. It makes a new us. It makes profits, it makes money, it makes returns, but it makes a new us. It makes a new mankind. We're what we create ourselves to be in resonance with this characteristically developing universe we live in. And what Kepler had done, overcoming the present to create a future based on that creative resonance, that's the key to redefining ourselves. That's the mankind that we have to create. So economic development, ending empire, those are necessary steps to fulfill this identity for ourselves which we have to embody. We yearn for economic justice. We demand peace. We demand an end to violence. And we must develop in our hearts that image of a better mankind that we intend to be, that more beautiful us that we will be in the future. We might ask ourselves, what will be that next chapter? Who will be writing it? So like Alexander Hamilton, I suggest that you take up your pen and put on your boots. Ignorance is itself a form of knowledge for Cusa. How could that be? He gives some examples. He says, one thing, in the infinite, a circle and a line no longer oppose each other. They aren't really different shapes anymore when you take these concepts and extend them to the infinite. This is a way of making a point about the infinite, even though obviously a circle and a line are easily differentiated when they're of a finite size. He says that God is the type of maximum to which nothing is opposed, not even the minimum. How can you have a maximum that's not opposite to a minimum? What kind of maximum is that? He says that we would attain a shadow of this vision of God. How to be right. It's certainly not how to discover anything. So Cusa distinguished between the world of the senses, the rational level of understanding based upon those senses, and a higher intellectual level of understanding that was reached only by contradictions among those senses. As an example of this, we can take how Cusa uses the infinite in Book 1 of his work called On Learned Ignorance, Didacta Ignorantia. There, Cusa uses geometrical analogies extended to the infinite to give a way for his reader to understand what his conception of God is, as a specific lack of knowledge. We're going to be hearing more about that. A specific kind of lack of knowledge, a learned ignorance, a specific kind of ignorance in particular, and to break through the Aristotelian way of thinking, which was based on logic, on syllogisms, frankly on words, on playing with words, categories that concepts are defined in, how phrases, logical phrases come together, and it was not based on letting nature itself speak. One particular tenet of Aristotle that Cousin and Kepler demolished was Aristotle's conception that you can't have both A and not A. This is something that Ayn Rand also gets very excited about. I guess that's an aside. So you got Aristotle, you can't have both A and not A. There are not contradictions. True knowledge is an avoidance of contradiction. That's how you know that you're right. Cousin gave examples of how that's actually not. There's been some, and this is an ongoing discussion. For example, on Wednesday on the weekly report or the weekly basement discussion here on the LaRouchePAC site, this was discussed from the standpoint of Vladimir Vernadsky and the ability to look at the human species as a geological force or as a biological force, and how if you examine the characteristics of the human species over historical time, it would seem as though you were observing a different species, that we change in ways that are seen only over evolutionary time in the biosphere itself. What I'm going to take up today is this Keplerian dimension of things. Kepler, the scientist, had put on the table and developed, really created modern science, and he did it in a way where he was very explicit about how he thought about those things and about the resonance, the connection, the similarity between the functioning of our minds and the functioning of the universe as a whole, which not only brought us science, but it brought us a proof of the magnitude of the power of the human mind, of the real magnitude of the human soul. So to address this question, how does Kepler give us an answer to what is mankind? LaRouche said, take two approaches to this. The classical approach of what Kepler had done in his day, and then also take the modern approach and how China is embodying this with their work at present. So first, the classical part of things. Kepler used a technique that was developed by Nicholas of Cusa, a technique that Cusa called the coincidence of opposites. And he used this to develop a new language for science, for astronomy